All right, so today we're going to do the walkthrough for the finding second derivatives implicitly homework assignment. So for this one, first step is just going to be use regular implicit differentiation to find the first derivative. And then once we have that, we'll take the second derivative. So to do that, we will start with the derivative of x squared, which is 2x, the derivative of y squared, which is 2y dy dx, and then the derivative on the right-hand side, which is just 1, because the derivative of x is 1, and the negative 2 goes away. So we will then solve for dy dx. So we end up with 2y dy dx equals 1 minus 2x, or dy dx equals 1 minus 2x, all divided by 2y. So we've got the first derivative. So now what we'll have to do is we'll just take the derivative of that with respect to x using the quotient rule, which we need to use the quotient rule because this is a quotient of two functions. So our second derivative is going to be the denominator, v, times the derivative of the numerator, which will be negative 2, so v du, minus u, that'll be our 1 minus 2x, times the derivative of v, which is 2, and since we're doing the derivative with respect to x, it's 2 dy dx. Then we'll divide it all by our denominator squared. And then we'll just simplify down a little bit, but the important thing to remember is that we always have to take our dy dx and replace that dy dx, or any dy dx terms we have in the second derivative with it. So our final answer here will be negative 4y minus 2 times 1 minus 2x times 1 minus 2x over 2y, all over 4y squared. And we could probably simplify this down just a little bit here. I'm not going to require you to do a common denominator here. This is the one time of the year that I'm going to say it's acceptable for you to leave your answer as a complex fraction. So what I think I'll do here is I'll just say that this is negative 4y minus 1 minus 2x squared over y. So I canceled the 2 with the 2 and brought the 1 minus 2x's together. And it gives us a 4y squared there. If you wanted to get it so that it didn't have a complex fraction there, we just multiply this negative 4y by y over y. So we'd end up with negative 4y squared minus 1 minus 2x squared all over 4y cubed. That one's not so bad, but the more complicated ones, I'm certainly not going to make you simplify that complex fraction. It just seems like unnecessary. So for our second one here, first step will be to take our derivative. The derivative of xy, we'll use the product rule, x times the derivative of y with respect to x, plus the derivative of x, which is 1, times y. And then our x cubed becomes plus 3x squared, and our minus y squared becomes minus 2y dy dx. And it all equals 0 because the derivative of a constant is 0. So I'm going to keep the 3x squared plus y on this side, and I'm going to move the dy dx terms to the other, which will leave me with a 2y minus an x. So I'm going to factor the dy dx out of this. And so once we do that, we can now divide and get dy dx is equal to 3x squared plus y over 2y minus x. Then we'll just come right in here and do a second derivative. It'll again be with the quotient rule. So we will have our denominator. So we'll have v times du. Well, that'll be 6x plus dy dx. And then minus our u, which will be 3x squared plus y, times our dv, which will be 2 dy dx for the 2y, and then minus 1. and it's all over our denominator squared. And from there, the only thing that we have left to do is replace our dy dx's with our dy dx term. This one, I'm definitely not going to ask you to simplify this any further. It's just kind of a nightmare, and it's kind of really just not necessary. So we'll replace that dy dx with 3x squared plus y over 2y minus x. And we'll replace the other one with 3x squared plus y over 2y minus x also. And it's still all over 2y minus x squared. And for our purposes, that's a perfectly acceptable answer. I don't mind if you leave these unsimplified. This is the one time a year that I'm going to tell you it's okay for you to not fully simplify. All right, and we got one more here. Again, we'll use the product rule for x squared, y squared. So that'll be x squared times the derivative of y squared, which will be 2y dy dx. Then we'll add to that the derivative of x squared, which is 2x, times the y squared. That's our product rule. And then we'll add to that our derivative using the product rule of xy. So that'll be x dy dx. Right, x times the derivative of y, plus the derivative of x, which is 1, times y. The plus 1 goes away, because the derivative of a constant is 0. The x becomes 1, and the y becomes dy dx. So I'm going to leave all these positive terms here. It's 2x squared, 2xy squared plus y on this side, and subtract the 1 from the right-hand side over to the left. And then I will keep my dy dx terms on the right side. So as I do that, I'm going to just do the factoring out. If I factor a dy dx out of dy dx, that ought to give me 1. And then I'm going to have a minus x from the x dy dx term as I bring it over. And then from the 2x squared y dy dx, I'll have a minus 2x squared y term. So we end up with dy dx is equal to 1 minus x minus 2x squared. Oh, I'm writing this backwards. Doing the wrong side there. Dy dx equals 2xy squared plus y minus 1 divided by 1 minus x minus 2x squared y. So there's our dy dx. I think we're going to need a new page to finish this one up. So let's just put this on a new page. Probably don't need this underlined part here, huh? And let's find our second derivative, and we'll use the quotient rule to do this. So our second derivative is going to be our denominator times the derivative of our numerator. Well, to find the derivative of our numerator, we're going to have to use the product rule, 2xy squared. So that'll be 2x times 2y dy dx plus dy dx. And then the minus 1 is a constant, so that'll go away. Oh, sorry, we're gonna go back here. 2x times 2y dy dx, that's the first half of our product rule. And then we have to multiply that by the derivative of the 2x, which is 2, times the y squared. Then we'll do our plus dy dx. And then our minus 1 goes away. So there's our v du. And then we'll do minus u, so that'll be our 2xy squared plus y minus 1. And then times our derivative of our denominator, well, that's going to be a 0 for the 1, a negative 1 for the x. And then the minus 2x squared y will become, with the product rule, minus 2x squared times the derivative of y, which is dy dx, plus the derivative of negative 2x squared, which is negative 4x, times the y. And then that's all going to be over 1 minus x minus 2x squared y squared. And now the only thing that's left is, since we don't have to simplify it, and you can be really glad we're not simplifying these, just put that dy dx in for all the dy dx's and sort of simplify what we can. We got 1 minus x minus 2x squared y. 2x times 2y would be 4xy, and then times our dy dx, which we'll replace. And then plus 2y squared, and then plus our dy dx. So we'll replace that one. And it's going to be a photo finish here on whether we can fit this all in on one side, or without going over at the end. We have minus our 2xy squared plus y minus 1. And then we have our negative 1 minus 2x squared times 2xy squared plus y minus 1 over our 1 minus x minus 2x squared y, and then minus 4x. I'm not going to fit that unless I just drag it over there. 4xy. We'll pretend like we can fit a parenthesis in there. And then it's all over that 1 minus x minus 2x squared y squared. There's clearly a ton of simplification that we could do with this, but again, I'm not going to require you to do it because these are just sometimes a pretty awful nightmare. So that's good enough. That's our walkthrough on how to find second derivatives implicitly. Just take the derivative implicitly, and then once you have that, take the derivative using the quotient rule implicitly again, remembering to replace all of your dy dx terms with your original dy dx. And that's it.